Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about quadratics for your upcoming test. So we'll start with solving quadratic equations. So what makes an equation quadratic is this x squared term here. We're not going to solve them as we would a linear equation in which we undo everything that's been done to x. Instead, we're going to solve by following these three steps. So let's look at this equation here. So one side is already equal to 0, so step 1's done. We're going to go to step 2, which is factorise. So when factorising, always see if there is a common factor. Here the highest common factor is 3, so I'm going to put that out the front. So now what I'm going to do is factorise what's left in the bracket. So I'll leave the 3 alone. Now I have perfect square minus a perfect square. For that we use difference of 2 squares. So we get 2 brackets. We square root the first. Square root of 4x squared is 2x. We square root the second. Square root of 25 is 5. One bracket gets a plus, one gets a minus. So I've done step 2 and factorised. Now step 3, I'm going to use the null factor law. The null factor law says if you have something times something equals 0, either the first something is 0, so that for us is the first bracket, or the other option is the second bracket equals 0. Now this is a linear equation because x is only in one spot, there's no x squared term. We can just do the normal, we're going to subtract 5 and divide by 2. So that gives me x is negative 5 over 2. This one here, I'm going to add 5 and divide by 2, so I get x is positive 5 over 2. So quadratic equations will have 0, 1, or 2 solutions. This one has 2 different solutions. All right, let's look at this equation here. So it's a quadratic because of the x squared term. So the first step, we need to make one side equal 0. So I can make this side equal 0 by simply subtracting 36. So I'm going to have x squared minus 5x minus 36 equals 0. Now this is a quadratic trinomial. It has 3 terms, no common factor. So what we do is we find 2 numbers that multiply to the constant term and add to the middle term, the coefficient of x. So to factorise it, we get our 2 brackets. So the 2 numbers that multiply to 36 and add to 5, we're going to use 9 and 4. So how do I get 9 and 4 to add to negative 5? Well, I can just make this a negative and this a positive. So negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. So I have factorised this and step 2 is done. Now step 3 is use the null factor law. The null factor law says if you have something times something equals 0, either the first something equals 0 or the second something equals 0. 9 equals 0, I just get x equals 9. If x plus 4 equals 0, x equals negative 4. These are my 2 solutions and I'm done. All right, let's look at a slightly harder question. So this equation here is a quadratic because of this x squared term. So we're going to follow the same 3 steps as on the previous slide. First step, make one side equal to 0. Well, that's already done for us. So let's go to factorising. Now, because this is a quadratic with 3 terms, a trinomial, no common factor, what we would ordinarily do is find 2 numbers that multiply to this number and add to this number. Now that would be challenging because 3, 4, 5, 6 is a big number with lots of factors. So instead we're going to use the method of completing the square. We're still following the same 3 steps as on the previous slide. It's just how we factorise, how we do step 2 that's changed. So when you're completing the square, you're writing the quadratic expression in this form. X plus or minus something squared plus or minus something. Now when we have a quadratic expression like this, we refer to a as the coefficient of x squared, so in this case a is 1, b is the coefficient of x, so b is 24, and c is the constant term, so negative 3, 4, 5, 6. So when you're completing the square, you just need to fill in these 2 boxes. The number that goes here is half of b, so we just divide that by 2. So 24 divided by 2 is 12. It is positive 12. Okay, now the problem is if we were to expand this, we wouldn't quite get this expression in blue. Instead, we'd get x squared plus 24x plus 144, not 3, 4, 5, 6. So to balance this out, what we are essentially doing, we're adding 144 here to make it a perfect square, and we need to minus 144 here. This is our perfect square, x plus 12 squared. So what goes out here is negative 3, 4, 5, 6 minus 144. It will become negative 3600. So when completing the square, the number that goes in the first box is simply half of b, half of the coefficient of x, and this number is equal to c minus that number squared. So the problem is that we haven't actually factorized this. This is not something times something, it's something minus something. But we can easily factorize this expression. It's a perfect square minus a perfect square. So to factorize the expression in green, we're going to use the method of difference of two squares. So to do that, we get two brackets. Now we square root the first, so the square root of x plus 12 squared is just x plus 12. So I'll put that in both brackets. Now the square root of 3600 is 60. One bracket gets a plus, one gets a minus. So this first bracket, well, 12 plus 60 is just 72 when you collect like terms, and 12 minus 60 gives you negative 48. So now we've factorized it, we've completed step 2. Step 3 is use the null factor law. The null factor law says if you have something times something equals 0, either the first something equals 0 or the second something equals 0. So of course, if x plus 72 equals 0, x is just negative 72. If x minus 48 equals 0, then x is just 48. So we have our two solutions and we're done. Let's now look at graphing parabolas. So parabolas are just the graphs of quadratic equations. So when the equation is written like this in completed the square or turning point form, you just get the turning point. So the negative of this number is the x coordinate of the turning point. This number outside the brackets is the y coordinate of the turning point. So the turning point's not enough to graph the parabola by itself. You also need another point, so you can find another point by finding the y-intercept. The y-intercept always occurs when x equals 0. So let's have a go at graphing this one here. So this is in turning point form. So the turning point is going to be the negative of this number, the opposite. So it's going to be positive 1 is the x coordinate. And then it's going to be this number as the y value of the turning point. We don't change the sign of this one. So let's go ahead and mark the turning point at 1, 3, which is about there. All right, that's the turning point of the parabola. What would be the y-intercept? So we just take our equation here and we're going to substitute x for 0. The y-intercept always occurs when x is 0. So you can put that straight on your calculator. You get 2 times 1 squared plus 3, which is 5. So the y-intercept is up here at 5. Now, because we know that this is the turning point where it stops and turns around, it's going to come down, stop at the turning point, stop and turn around, put arrows on the end. That is the graph of this. Now note, this has no x-intercepts because of what we showed in the previous slide about factorization. You can factorize the difference of two squares, but here we have the sum of two squares with the plus. So when you have a square plus something else, you can't factorize it. That's why there are no x-intercepts. All right, let's look at another example of graphing. So here the equation that we want to graph is not in turning point form, so we're going to use completing the square. So remember, completing the square, I want to write it as x plus or minus something squared plus or minus something. Now, you will have a number out the front sometimes, as we did in the previous example. So when you're completing the square in something like this, if the coefficient of x squared is not 1, if it's not just an x squared by itself, you need to use highest common factor method to take it out. So I'm going to take out a factor of minus 1. So that will leave me with x squared minus 2x minus 3. Now I'm going to leave this negative 1 alone and perform completing the square on just this part. So leaving the negative 1 alone, let's perform completing the square on this. So what I do is I get my brackets. Now the number that goes inside with x is half of b. b here is -2. Half of that, of course, gives me -1. So on the outside, I take my -3 and I need to subtract this number squared. So -1 squared is +1, so I subtract that. So I have y equals -1, x minus 1 squared minus 4. So to get it looking like this, so I don't have this extra set of brackets, I'm going to times -1 by this and then -1 by that. So what I actually end up with is -x minus 1 squared plus 4. Okay, so I know now that the turning point is going to be 1, 4. The negative of this number is the x-coordinate, this number is the y-coordinate. So let's go ahead and mark the turning point. 1, 4 is there. Okay, what would be the y-intercept? So for the y-intercept, I replace x with 0, so I get -0 minus 1 squared plus 4. I actually get y equals +3. So the turning point is here, y-intercept is here. So now let's have a go at finding the x-intercept. So just as we let x equal 0 to find the y-intercept, we let y equal 0 to find the x-intercepts. So I'm just going to replace here y with 0. So I get 0 equals minus x minus 1 squared plus 4. This is actually the difference of two squares, because I can easily rewrite this as 4 minus x minus 1 squared. I have a perfect square minus a perfect square. So to factorize that, I'm going to get 2 brackets, square root the first. Now when I square root the second, I'm going to put it in brackets. So I've got x minus 1, and then one bracket gets a plus, one bracket gets a minus. So this first bracket, when we clean it up and collect like terms, becomes 3 minus x. And this bracket here becomes 1 plus x, or x plus 1. So if I'm solving this equation, I just use the null factor law. Either the first bracket equals 0, which would mean x equals 3, or the second bracket equals 0, which means x is -1. So the x-intercepts, where it hits the x-axis, will be here at -1 and here at +3. We now have enough to graph it. Make sure it stops and turns around at the turning point. There we are, the graph is done. Let's now look at some applications of quadratics. So the perimeter of a rectangle is 96 centimeters, the area is 476 centimeters squared. Calculate its dimensions. When you're doing a worded problem, always start by letting x equal one of the things you're trying to find. So here we want the dimensions, we want the width and the length. So I'll just let x be the width. Now, if I have a rectangle whose perimeter is 96, that means it's 96 all the way around. That means its length plus width is half of 96, so 48. So width plus length equals 48. So, of course, that means that y, the length, is 48 minus x. Now we need to do this step because we don't want a quadratic equation that has y's and x's. We don't know how to solve them. We need a quadratic equation that only has one variable. So if there are two things you need to find, you need to write the second thing in terms of the first thing. You need to define here length and width both using an x. So if the width is x, 48 minus x equals the length. So we're told that the area, so width multiplied by length, is equal to 476. All right, expanding the brackets gives us 48x minus x squared equals 476. This is a quadratic equation because it has an x squared, so we need to first make one side equal to 0. So I'm going to add x squared to both sides, and I'm going to subtract 48x from both sides. I get x squared minus 48x plus 476 is equal to 0. Now, this might seem a bit hard. 476 is a big number, so to find two numbers that multiply by it is not easy. So instead, we might use completing the square. So for completing the square, it's going to be x minus 24 squared. Why did I pick negative 24? Because it's half of b, half of negative 48. So over here, I have to go 476 minus 24 squared. So 476 minus 24 squared, you can just use your calculator to get that. So now I use difference of two squares. I'll get my two brackets, square root the first, square root the second, square root of 100 is 10. One bracket gets a minus, one gets a plus. So the first bracket, negative 24 minus 10 is just minus 34. And the other bracket is, of course, just x minus 14. So using the null factor law, I get x equals 14 and 34. They are the two dimensions, width and length. 14 centimeters and 34 centimeters. We're done. Let's now look at another worded question. So remember that a parabola is just the graph of a quadratic function. Now parabolas will either look like this, smiley face, or frowny face. If it's a smiley face, the turning point here is called a minimum turning point. And the function has a minimum value. By minimum value, we're talking about the y value. And similarly, if it is a frowny face, it will have a maximum y value. So we can use this to find the minimum or maximum value of quadratic functions. And it turns out whether it's a minimum or a maximum, it always occurs when x equals minus b over 2a. So we can use this to solve minimum and maximum problems. Let's look at one such problem. So price of rooms at a hotel is given by 600 minus 12x. X is the quantity sold. Calculate the maximum possible revenue. So here, I'm just going to let y equal the revenue. So let's come up with a function for y. Well, revenue is just quantity sold times by price. So expanding this, I get y equals 600x minus 12x squared. The question is essentially asking us to find the maximum possible value of this function. I know it'll be a maximum because if we were to graph this parabola, it would look like that because the coefficient of x squared is negative. So let's find the maximum possible value for that. Now that occurs when x equals minus b over 2a. It doesn't matter the order in which it's written. B is always the coefficient of x. A is always the coefficient of x squared. So the maximum value of this function occurs at minus b over 2 times a. And putting that on our calculator, we get 25. What we found is the revenue will be maximized when 25 rooms are sold. So the revenue, if 25 rooms were sold, you just have 25 rooms. The price would be 600 minus 12 times 25. It'd be $300 per room. So the maximum possible revenue is $7,500, and we're done. All right, let's now look at circles. So if we have an equation of this form here, it is a circle. The negative of this number and the negative of this number, they give you the center. Predictably, the one in the brackets with x is the x coordinate of the center. The one in the brackets with y is the y coordinate of the center. Now the radius is r, it means it's the square root of this number. So if I want to graph this here, it will be a circle because its equation is of this form. So the center of this circle, we call it usually O for origin, it will be the negative of this, giving us the x coordinate of the center, and it's supposed to be the negative of this, giving us the y coordinate. Now if no coordinates written there, it will be 0, because of course y squared is the same as y plus 0 squared. So the center of this circle is negative 2, 0, which occurs here. Now the radius of this circle is the square root of that number. It's the square root of 4, which is 2. So I know that the center is here. The radius of 2, to graph it, just go 2 in all directions. 2 to the right, 2 to the left, 2 up, and 2 down from the center. So the circle will go through here, 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 and here. All right, so just join it up in a circle. I know I'm terrible at drawing circles, but there is the graph of this relation here. All right, last thing we need to do is look at finding the equation of the graph. So let's start by finding the equation of this circle here. Now we know that because it's a circle, its equation will be of this form. So all we need to do is find h, k, and r. So h and k can be easily found from the center. The center here is at -1, 3. Remember, these are the opposites of those numbers. So because the x-coordinate of the center is -1, it will be a +1 in the x bracket. And because the y-coordinate of the center is +3, it will be a negative inside here. All right, so what is the radius of this circle? Well, if we look here, we go up 3, and we go across 3, down 3. So what that means is the radius is 3, so the number that goes here is 3 squared, and 3 squared is, of course, 9. So what we found is that we would need to start with this equation to end up getting this circle. All right, let's look at this one here. We're looking now at the graph of a parabola. Now we know that the equation of any parabola can be written in this form, so we just need to find a, h, and k. So h and k can be easily found from the turning point. The turning point here is 1, 0. So what that means is the x-coordinate of the turning point is 1. This number will be a -1. This number here is just the same as that there. So in this case, it's 0. So our equation thus far is y equals a x minus 1 squared plus 0. I don't really need to write the plus 0 out here. Now, all that remains to be found is this value of a. We'd get the same turning point here, whether a was -3 or +20. We need to find a. To do that, we need to sub in another point whose coordinates we can clearly see. So I'm actually going to pick this point here, which is 0, -2. So the x-coordinate here is 0, the y-coordinate's -2. So into this equation here, I'm going to substitute y for -2 and x for 0. So, of course, order of operations means we do this first and then square it. So -1 squared is just 1. I get -2 equals a times 1. A is just -2. So that means the equation of this parabola is y equals a x minus h squared. We figured out h was -1 plus k, which is 0. So that's the equation I need to start with to yield this graph here. All right, thanks so much for tuning in, but best of luck studying. I'm sure you'll ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.